Hey, what's up everyone? This is John Haddad, cqlengine tutorial number 2. Today we're going to be doing a little bit of data modeling and building on our previous tutorial. One of the first things that we did in the previous tutorial was we set up a custom test runner for nose. The reason why we did this instead of running the nose shell script is we actually want to sync all our models to our database, which is going to let us iterate very, very quickly every time we want to run our tests. So one thing to take note of here is we're actually using a plain old UUID as the photo ID. And while this is cool and gives us a unique identifier, it doesn't actually help us as far as querying capability. So what we really want to do is drop this table and start over with our photo data model, and instead we're going to use a time UUID. And the really cool thing about a time UUID is that it has a timestamp embedded in it, but it's still a UUID. And so what you get out of this is internally Cassandra's going to sort the data on disk by the timestamp embedded in the UUID. We're going to go ahead and rerun our unit tests. We can then take a look at the schema, and we can see now that we're using a time UUID instead of a regular UUID. This is pretty cool because now instead of treating these photos just like a bucket of things that are all together unsorted, we now have a list of photos that are sorted based on when they were created. So this is extremely useful for sites like Instagram or Twitter or Facebook, anywhere where you want to have a feed of information where your newest stuff is always appearing at the top and you want to get at that data quickly. Now we're going to go ahead and make one tiny change to this model. We're going to make the clustering order be in descending order. That means when the data is stored on disk, the greatest stuff is going to be in the front. So our newest stuff will be there. So basically, whenever we ask for a bunch of photos, we're going to get the newest stuff first. We can verify that the newest things are going to come back by running a simple test. This is definitely not the kind of test that you want to run in your real code base, but I think for this example, it'll illustrate what we're trying to do just fine. So you can see here that we're going to go ahead and create 10 photos that belong to a particular user, and when we query for them in our tests, we're going to see that they appear with the newest ones first. Alright, now we're going to go ahead and run our tests, and we can see that we start at 9 and count down to 0. The next thing that we're going to take a look at is table polymorphism. Basically, table polymorphism lets you use inheritance to define your models, and you can have a common base type. Here, what we're going to do is we're going to abstract away some of the stuff around photo, and we're going to have a generic class called content. And underneath that, we're going to have photo, and we're also going to have video. When we work with table polymorphism, we have to define a column as the polymorphic key. And basically what that's going to do is it's going to store a little bit of extra metadata on each row telling us what type the model was originally created as. Each of the subtypes, photo and video, need to define the double underscore polymorphic key attribute. The next thing that we're going to do is create a simple test that creates two objects, one photo and one video. We're then going to pull them back for this given user, and we can see that the two objects are actually now in the same timeline of content. This is because internally cqlengine is actually storing everything in the single content table. That content table has all of the attributes of content as well as all of its subclasses. We can now update our test runner to include video in the tables that are going to be synced. We can tell here that I've made a little mistake, and each of my photo and video classes are subclassed of model. Really, they need to be subclassed from content. When we run our tests, we can see that I screwed up and the primary key is not defined on the video class, or the photo class for that matter. So we go back, change them to subclass from content, and all our tests should run. We can then check cqlsh and the tutorial key space, and we can see that the new content table has been created. There are going to be situations where you don't want to pull back photos and videos. Maybe you want to just pull back lists that are broken down by content type. To achieve this, we're going to need to add a field called indexed to our polymorphic key. And what that does is it tells Cassandra to create a secondary index around the polymorphic key. Once you have that, you can query for the subtypes. So for instance, if you want, you can just get a list of videos back. You should now be able to use timeuuids and clustering keys to create interesting timelines. You can use table polymorphism to put different types of objects in a single partition. Finally, you can put an index on your polymorphic key to pull back objects of a specific type.